Good afternoon, and welcome to our Distinguished University Professorship Lecture Series. This is a very special afternoon for both our recipients and our community. A Distinguished University Professorship is an exceptional honor that recognizes the embodiment of our mission of teaching, research, and service. It symbolizes our commitment to improving the public good through scholarship, education, creativity, and mentoring. Through the decades, the university has recognized extraordinary individuals with this honor. This includes the epidemiologist Tommy Francis, who led the massive trials that proved the polio vaccine was safe and effective. James Neal, who established the nation's first academic program in genetics, right here at Michigan. And Linda Gregerson, whose award-winning poetry explores the human condition. And June Manning Thomas, an urban planner whose research shed light on racial equity and urban development. We are fortunate to be joined today by some of the esteemed recipients of this professorship who are here to celebrate their colleagues. For those in our audience, if you are a Distinguished University Professor, could you please stand? Thank you. Today, we are expanding this pantheon of U of M academic excellence with three scholars who will share their expertise and insight. They are Sergey Fomin, the Richard P. Stanley Distinguished University Professor of Mathematics. Do you want to stand? Anna Stefanopoulou, who is the Wei Peng Distinguished University Professor of Mechanical Engineering. And Christian Davenport, the Charles Tilley Distinguished University Professor of Political Science. I would now like to introduce my colleague and the university's Chief Academic Officer, Lori McCauley, who will tell us more about today's recipients.
Thank you, President Grasso. It is just so nice to share this event with you and my colleague, Dean Mike Solomon of Rackham, who will join for the Q&A. Welcome to all of you. This is just really the best of the best at our university, and we're in for a treat. It's delightful to share this event with you. We're going to hear from three newly named Distinguished University Professors, each who will offer a window into their careers of remarkable achievement and into questions that keep moving their fields forward. It also showing really the recognition that our campus brings through the work that they have done. So it's my privilege to introduce each of these speakers. Let me start by welcoming Sergey Fomin, the Richard P. Stanley Distinguished University Professor of Mathematics and Professor of Mathematics in the College of Literature, Science, and the Arts. Professor Fomin has made contributions to modern mathematics that can only be characterized as breakthroughs. In collaboration with Andrei Zvolinsky, he introduced and developed the theory of cluster algebras, a foundational idea that has generated important applications across multiple fields and has reshaped how many mathematicians think about structure and transformation. He's a member of the American Academy of Arts and Sciences. His work has been recognized with the American Mathematical Society's Steele Prize for seminal contribution to research. He's a fellow of the American Mathematical Society, a member of its council, and a former chief editor of its flagship journal. His lecture this afternoon is titled Weave Patterns and Projective Geometry. He'll describe a newly discovered connection between two classical subjects, the combinatorics of interfacing weave patterns and the geometry of line configurations in the projective plane. Please join me in welcoming Professor Sergei Fomin.
Thank you very much. Thank you, everybody, for coming. I'd like to start with acknowledgments. Of course, thanks to President Grasso, Provost Macaulay, Dean Solomon, and the selection committee for this extraordinary honor. I will be mostly reading from the slides because the English is not my native tongue, and I'm worried about not fitting into 20 minutes, so please excuse me for that. I'd like to briefly mention my gratitude to my mentors in St. Petersburg, Boston, and Ann Arbor, my colleagues and collaborators here and elsewhere, my students, some of whom are here in the audience, both undergraduates and graduate. Of course, my family members and friends. Okay. And also, I'd like to give special thanks to Richard Stanley, the namesake of this DUP, who is here in the audience. He is the world preeminent authority, essentially a founder of my field of algebraic and geometric combinatorics. And he's, of course, recipient of many honors and awards, some of which are mentioned here on the slide. I first met Richard in January 1992 in Sweden during my first trip as a research mathematician across the Iron Curtain. And this meeting has changed the course of my life and that of my family. We came from Russia to the United States later that year. I worked at MIT starting that year until 1999 when I came here to Michigan. And during those 7 years, Richard was an invaluable mentor to me, and I'm really grateful and thankful, and it's a wonderful opportunity for me to sort of pay back my debt. Thank you, Richard, for believing in me and for all your generous support and advice over these years. I don't know, I don't want to embarrass you by having you to stand up, and but here you are. All right. So what is this field of algebraic/geometric combinatorics? So this is a 20-minute talk for a general audience, so it's very hard to explain it, but just very briefly, some of the key features of the subject are applying algebraic or geometric methods to solve problems in combinatorics, also known as discrete mathematics, using combinatorial insights to advance algebra or geometry, and recognize common combinatorial patterns that arise in different contexts, and then using them to establish connections between different fields of mathematics. So I will illustrate all of this using an example that has already been mentioned in the introductory remarks by Provost Macaulay. So the goals of this lecture include illustration of how combinatorics really helps to shed light on classical problems in geometry, I will try to highlight connections between mathematics and art, reaffirm that mathematics is timeless, and we really use and rely on results and concepts that have been introduced centuries ago. And I will also try to dispel the common myth that mathematics is a young person's game, because the results that I will introduce were obtained by me in my 60s, of course, with a younger collaborator. So this talk is based on joint work with Pasha Pilavsky from University of Minnesota, and is an example of a Russian-Ukrainian collaboration. So what is linear incidence geometry in the plane? It studies configurations like this one, where you have a bunch of lines on the plane, and some of them intersect in sort of non-generic ways, where you have more than two lines crossing it at the same point. The oldest incidence theorem in history is almost 2,000 years old. It goes back to Pappus of Alexandria. So what does it say? Let's draw two arbitrary lines on the plane and pick 3 points on each of these two lines. Okay, so there is the blue line and the red line. Pick 3 points, any 3 points here, any 3 points there. Then connect them by these black lines that go across, as shown here. Then find these 3 points of intersection, and miraculously, voila, these 3 points will always lie in a line, okay? So, amazingly, this doesn't rely on any measurements, right? We don't have to assume anything about distances, angles, areas, anything. And no matter how you chose the original 6 points on the two lines, this statement will hold. That's what makes it a result of incidence geometry. So it's a pure statement of position. The second oldest theorem is much more recent. It's merely 400 years old, due to Gérard Desargues. So here we have 3 lines crossing at a point. We choose 2 points on each of the lines, a red point and a blue point. We connect the red points by red lines, the blue points by blue lines. Then we find the points of intersection. And those 3 points magically will lie in a line, always, no matter how you chose the original 6 points. Isn't it amazing? All right. Again, no measurements, right? So we did not require anything about the distances or angles or anything like that. So these are just 2 of dozens of such statements that have been discovered over the centuries. And one can't help but wonder, where are they coming from? Is there a system behind these statements? Until recently, surprisingly, there has been no satisfactory answer to this question. So in joint work with Pasha Pilavsky, we suggest an answer to this question via what we call a master theorem of linear incidence geometry, from which all statements of this kind can be obtained as special cases. And our construction is based on another classical mathematical topic, which is interlacing weave patterns, also known as alternating links. So here you see a knot, and it has this interlacing property that it goes over and then under, and then over and then under, and then over and then under as you trace it. Okay, so that's the feature. And these kind of weave patterns go back centuries, if not millennia. These are 4 contexts in which you can encounter these patterns in everyday life. I'm not going to discuss the mathematics of braiding or basketry and so forth, but These are historical examples, go back 2,000 years. These are mosaics from Roman theater in Syria, what is now Syria, and from Sicily. You can see that these are interlacing weave patterns of exactly the kind that I mentioned. And these are even more spectacular examples from medieval Islamic art. Again, I don't know if you can see in this picture from Alhambra how these strands go under and then over and then under. Beautiful pictures. So there are two general types of weave patterns. They can be bounded, like on the Celtic cross on the left, or they can be periodic, like on the window detail from Cordoba on the right. They correspond to alternating link diagrams on the sphere and on the torus, respectively. So how does that connect to the subject of incidence geometry that I mentioned earlier? Let me explain this connection that we discovered. First, you start with a weave pattern, and you color the faces in alternating way, in this case, gray and white. And we are going to associate a point, respectively a line, in another plane to these regions. So I'm not going to color these regions in on the subsequent slides to make them more readable. At each crossing, we will have two gray adjacent faces and two white ones, which will correspond to 2 points and 2 lines. And I will call this crossing coherent if the 2 lines and the line that passes through the 2 points all pass through a common point. Okay, so here, back. Here we have 2 points, A and B, and 2 lines, P and Q. And I want those 2 lines pass through a point that lies on the line AB. If that happens, then I say that this configuration is locally coherent. And here is our master theorem. Let's take an interlacing weave pattern, either bounded or periodic. Associate points and lines to the faces of the weave pattern, as explained before. Make sure that none of the points lie on any of the lines. And then assume that all the crossings, from the exception of one, are coherent, satisfy this condition that I just presented. Then the remaining condition is forced. Okay? That's what the theorem says. I will illustrate it in examples. So, as I mentioned, this is a general setup that is going to cover all the known classical theorems of planar incidence geometry. Let me illustrate how this happens using, as examples, the theorem of Pappus and Desargues that I told you about earlier. So to get the Desargues theorem, we will need to use one of the most beautiful and simple bounded weave patterns known as the Borromean rings. Here you can see it in the picture. Of course, this also goes back millennia. These are examples from emblems of various nobility. And here is from coat of arms in Sweden. So these go back centuries. How do we get Desargues' theorem? So we take the Borromean rings on the left. We label these 4 regions by points, A, B, C, D. We label the remaining 4 regions by lines, P, Q, R, S. And then we try to satisfy this coherence condition. Like, for example, at this crossing, we have 2 points, A, D, and 2 lines, Q, R. So I want R, Q, and DA to pass through a common point. Okay, where is R is here, Q is here, and dA is this line. Okay, they pass through a point. And then this crossing, A, C, Q, and S. Q and S cross here, and AC passes through that. So for each of these crossings, there is some kind of incidence condition. And if it is satisfied for 5 out of the 6 crossings, then the 6th condition is forced. And as you unfold it and just figure it out and see what it means, you will see that it exactly means that this last collinearity of these 3 points is forced on you by the other conditions. And so you recover Desargues' theorem. Ordinarily, I would ask for questions, but I'm afraid people will be shy to ask them. Okay, let's now get the Pappus theorem. So that one can be obtained from one of the simplest periodic alternating weave patterns, namely the Kagome lattice, which goes back to Japanese basketry. This is shown here at the left. This is a floor design in Florence's synagogue, where you also see the same, actually, combinatorial pattern as on the left. So you start with this periodic pattern. You need to decide how to label it. Here you have some choice, because the labeling should also be periodic, but you need to choose like a fundamental domain of periodicity, and then it will be replicated throughout the entire plane. For the particular choice shown on the left, we get indeed the Pappus theorem as shown on the right. So let me illustrate. For example, here, A, B, P, Q surround this crossing. So the lines PQ intersect here, and the line AB goes through this point. Okay? So the coherence condition is satisfied here. And of course, all of them are satisfied, but if you take all of them with the exception of one, then one remaining condition will be forced, and that you can choose it to be the condition that these 3 points lie on a line, which is the conclusion of the Pappus theorem. So it follows from the remaining ones. Okay? So it's pretty miraculous that this construction, which is not suggested at all by the original geometry of these classical theorems, actually explains what's going on here, and that's the beauty and power of our theorem. So what does it buy us? Well, this explains in a uniform way the origin of all these classical theorems. It can be used to connect incidence geometry to other areas of mathematics, as we explain in our paper. It suggests a general method for generalizing existing theorems, and it helps explain why some of these theorems are more powerful than others. And among generalizations and further research directions, let me mention that you could consider weave patterns on surfaces of higher genus with lots of handles, like here, for example. You can push it to study projective geometry in higher dimensions, and also generalize it to incidence theorems for curves and surfaces of higher degree, not just lines on the plane, but as in this case, hyperbole and ellipses, and of course could be surfaces and so forth. And also obtain theorems involving tangency condition, like the Poncelet phenomenon illustrated here in this picture. And there is a lot more. Well, I guess that's it. Thank you.
Thanks very much for that wonderful lecture. We have time, several moments for questions from the audience. And I am happy to begin. It's just, as you said miraculous, I would say mysterious. It's just amazing that these two different objects or ways are related in this way. And I have a kind of two-part question. One is there potentially kind of something else behind those two, like a common framework that is out there that would allow you to understand why these two instances are, in some sense, part of the same thing? And then I'm also just really interested in when you brought your weaves forward, the weaves kind of matched they were exactly the right weave needed for that particular construct. And could you talk a little bit about your discovery process? Did you know that was the right weave, or did you have to examine 10,000 weaves to get that one to work? Thank you.
Thank you, Professor Solomon. Yeah, these are sort of the right questions to ask. Some people in the audience might think that I told you to ask these questions, but we actually didn't discuss it at all. But these are exactly the two questions that I wanted to be asked. So one question is like, how did we, to rephrase it, like how did we discover it? And so this was in the process of pursuing some other research direction, which actually involved cluster algebras that were mentioned in the introductory remarks. And while working on that project, we just stumbled upon some connection that, because we knew about this open problem, about explaining incidence theorems, so this struck us as being too good to be true, like it cannot, like. So you make this discovery not because you set out to discover it, but you just know that something is an open problem, and you just hope that one day you will stumble upon something that will help you answer that. Now, another question is kind of deeper in the technical sense, and it is how to engineer a interlacing weave pattern for a given theorem. Like you are given a particular theorem, like Pappus or Desargues, right? And then you somehow need to pull out of a hat, a weave pattern that would enable you to prove that theorem. Where does that come from? And it turns out to be a difficult question that we don't really have a satisfactory answer to. So this, at the moment, it remains more an art than science. So it requires human intervention. Maybe we can train, an AI engine to help with this, like, train a neural network on a bunch of examples and then ask them to do it. But we don't have an efficient algorithm for constructing, for sort of reverse engineering an alternating strand pattern from which a given incidence theorem could be deduced. Thank you very much for your penetrating questions.
Other questions from the audience? Yes, one in the back. Thank you. Sorry, there's a microphone coming around. I apologize if you could ask your question.
Sure, thank you. Going the other direction towards physics engineering, and maybe you just touched on this with the weave patterns, but can you think of some potential practical examples in the future where this could make a better basket in simple terms?
Yes, some of these constructions are indeed used in architecture, but I really am not the right person to answer these questions. I'm motivated by the beauty of these constructions, by sort of mathematical elegance of the answers, and history shows that even when you don't have practical applications in mind, with time, these technologies find applications, and in surprising ways sometimes, yeah. But that's where I am coming from.
One final question. Thank you.
It's kind of bold to call something a master theorem. Is that what you really called it, or is that just for this talk?
No, we did call it in the paper because all of these classical theorems already existed, right? And we wanted a title that would somehow convey the fact that this is a common generalization of all these theorems. So that's the best I could come up with. Maybe people will later call it something else. Yeah.
Thank you. Please join me in thanking our distinguished university professor again.
Thank you, Professor Foman. I really appreciated your connection between math and art and referencing back to early centuries where mosaics demonstrated. It made me wonder about those connections, and are they still similar today? Are we still displaying math in our art the way that we did centuries ago? But that's for another time. Okay, it is now my pleasure to introduce Anna Stefanopoulou, the Hui Peng Distinguished University Professor of Mechanical Engineering. She's also the William Clay Ford Professor of Technology, a professor in mechanical engineering, as well as in electrical engineering and computer science in the College of Engineering. Professor Stephanopoulou's work has helped shape the modern landscape of advanced propulsion and electrification. She founded the world's first academic research group focused on fuel cell and battery control, led breakthrough efforts that created digital twins of advanced propulsion systems, and developed sensing and calibration algorithms that have become critical to electrified powertrains. Her scholarship, patented inventions, and deep industry collaborations have informed work at the Environmental Protection Agency, the U.S. Department of Energy, and the United Nations. And she has mentored generations of engineers and researchers along the way. She's also an elected fellow of the Institute of Electrical and Electronics Engineers, the American Society of Mechanical Engineers, the Society of Automotive Engineers, and a recipient of major international awards for innovation and education. And in fact, today, she's going to be honored for the 2026 Lifetime Achievement Award from the Trade Association for Advanced Battery Technology in North America, an event that's taking place in Arizona. She definitely had a conflict, and we are just thrilled that she decided to be here with us and to celebrate the work that she's done here. So her lecture is titled Battery Midlife Crisis and Decisions, from Preventing Battery Meltdowns to Giving Aging Cells a Second Life. The lecture shows how digital twins quietly steward batteries from factory floor to final recycling. Please join me in welcoming Professor Anna Stefanopoulou.
Thank you very much, Provost Macaulay, President Grasso, Presbytera Susan, and Dean Michael Solomon, and everybody else, in fact, that have nominated me and recommended me in getting this award. So after this principled presentation, mine is going to be chaos, but lots of pictures and stuff. So we'll have to see how it works. So I want to start, of course, with Hui Peng. Here's the ME, Mechanical Engineering fans. And Hui Peng was the pioneer in the area of automated vehicles, actually started with vehicle dynamics and safety. And he was the director of MCT. He was director before that of the actual US-China Clean Energy Institute. We used to have these things, amazingly. And so many other things. I actually came to U of M because of him, partly because of him. So it was great. Some pictures here. So this is the jewel of North Campus and U of M, the automotive laboratory. It's actually about 100 years old, and we're looking for funders to actually renovate it. I'm kidding. Okay, so this laboratory with Dre Bayman, the director, actually, this is where myself and Wei Peng were down at the basement of the Auto Lab. And you can see here in the pictures working with students, building little automobiles, but doing heavy research on big industrial, large diesel engines. But also having a good time. I think Lauren is here and Valerie. And I want to say thank you very much to Hei Chun. She's here with us. Hei Chun, there, the widow of Professor Peng, and Lauren and her spouse. Okay, so we are doing so much in the Auto Lab, and apart from working on engines, we were also actually the first, like Provost Macaulay said, one of the first academic, actually university-based laboratories for actually testing fuel cells. We wrote a book with Wei Peng, one of the first books, and some free open source code that actually was used all over the world, and of course here in the many laboratories. You can see here, this is a picture from a year and a half ago from the GM manufacturing laboratory, just east of here, and they're still using some of these algorithms and actually models, digital models. Again, I am just going to brag about the Auto Lab. This is a laboratory that has this ability. Each one laboratory is very dedicated, expensive, precise measurements technology for emission and fuel economy. It started with a lot of internal combustion engines, as you can see when I started. We could actually connect through communications these engines that they were actually running on dynos and pretend and have a virtual emulation of a whole highway system. So this picture actually shows that we can actually measure very, very detailed emissions and fuel economy from automated connected highways that actually have a mixture of vehicles. And actually working with the laboratory at Dearborn, the idea was to actually even connect with that, connect with Clemson, and actually all over the world being able to actually connect and do these experiments. So it was actually interesting because with Wei Peng, we were not like always, we could actually compete, right? And here's a picture from a group of us in engineering that actually leveraged the automotive laboratory and competed against each other. And we all get granted through the ARPA-E to do all these different projects. The actual project, the wording here was, can thin air power a car? And the idea was that actually we were using communication and the connectivity between the vehicles to actually increase the fuel efficiency, basically avoid fatalities and things like that. So this was a fun group to be around in the North Campus. As I alluded, I started with a lot of internal combustion engines, right? So you can see here, I was very privileged to work actually in the National Academy of Engineering study in 2012 about the future fuel economy standards, and not just the standards, but the cost effectiveness. So what you see in the axis at the bottom, at the x-axis is actually US dollars, and as you add actuators and you add technology, you're actually increasing the cost, which is the y-axis. So you can see, actually, the y-axis is miles per gallon, so you increase the fuel efficiency. You can see where diesel and hybrids are, and it was pretty clear that in 2025 target fuel economy back 10 years ago, 9 years ago, actually, we would have to really embrace plug-in hybrids and electric vehicles because we couldn't actually meet with regular engines. And even hybridization was even low. I put the heart there because I was actually working on some light tweak a little tweak of the diesel engines, because the diesel engines were amazingly, in a sense like we saw in Europe, they had really good fuel economy, almost the same with hybrids, but actually they were cheaper. So hey, why not? So they were more affordable. So I guess after a lot of work, we realized that actually the software that was the enabler was also the enabler for, unfortunately, cheating, and broke our heart. And many of us, really understood that we really need to, really focus on the electrification because we can't push forward. So batteries, hey. So. This is the batteries now story, and focusing on that, I'm going to use a little diagram done by my daughter when she was middle schooler, just getting out of COVID, and she said, you explain batteries, but I want to do it really simple. So batteries is like 5 layers. It's a system that has 5 layers. So you have at the end copper and aluminum. Next to it, you have actually the graphite and the metal oxide, which are the kind of active material. The magic is the separator that does not allow electrons through, but that lets the lithium go through. And so basically you have lithium go through in this electrolyte in this anode and cathode and goes back and forth, and the electrons cannot go through the separator, but they have to go around through the circuit, and that's how you get electricity. Boom, very simple, right? So you can see it like that. You take these 5 layers, you roll them up, and you stuff them in a cylinder. That's a cylindrical battery, or you stuff them in a pouch, and it's a pouch cell, et cetera, et cetera. So this is the principle. Now, if I have to pay attention, basically look at the lower left corner. So we're talking about using carbon, and carbon is the one that sort of material that the lithium packs in, and then on the other side is the metals. So this carbon and silicon typically are on the one side, and then we have these expensive metals on the cathode side. So expensive cobalt, manganese, nickel, and we're moving towards iron. So these are these very expensive metals, and of course that was the periodic table, and I don't expect you to actually understand this, but the way what I want to show you with this graph is like all this soup of acronyms that come from our metals and our various atoms and molecules. It is a big race. So choosing the right material and the right combination between anodes and cathodes is what is happening. You can see the star where the actual invention of the battery, of the rechargeable lithium-ion battery was in 1991. A few years ago, we got the Nobel laureates for that. And then you see the Panasonic eliminating a lot of camcorders and a lot of our cameras and things like that, because now we could have this nice battery, this heavy cameras that we have before. And so Panasonic continue, and you can see actually some of our goals. And what I want you to pay attention is over the years, these goals are still high. We haven't reached them yet, but you can also see that we're starting to saturate. And as we start to saturate with materials, guess what? People like me that I'm working on the system show up. Because once the materials get stabilized and get to be as best as possible, then myself, that I work on the system level, I need to actually cut the cost, make it durable, make it last longer, and make it actually achieve and optimize the overall system. So depending on what the application is, the previous graph, did you notice the x-axis? I'm going to go back again. It's energy density. That's the holy grail, right? Energy density. We're trying to stuff as much lithium as possible in 1 kilogram of stuff, basically, and get it back and forth will give us the watt hours. And then, but energy density, power density, and cost are not the only metrics. Depending on the application, other metrics are things like life cycle, calendar life, safety. So this is where we are, and that's when I realized, this is what I can actually do. So we're talking about batteries. If I can actually, with my system, stretch the actual lifetime of the battery and help it go through its middle lives and several lives and make decisions. You can see these little computers in this circular economy. So you have the beginning of making, building, and then you have to at some point decide if you're going to reuse this battery, if you're going to repair it, if you're going to repurpose it, or if you're going to send it for recycling and then meet the actual raw material and reduce the mining. So these little computers are these algorithms that help you make this decision. So middle life crisis and decisions. If you were here to hear about my middle life crisis, no, it was about batteries. Okay, so here what we have is basically these decisions and being able to actually compute and understand how long the battery is going to last, how good it is, and how long it's going to last, and if it's worth it to do something more with it before it just gets disposed, which is ideally we don't want to do. So we have basically here the battery first act. Okay, so it's obviously somebody that takes care of batteries, and I'm going to get into my big hit slide, which I will repeat. Batteries are like humans. So they hate to be overworked. They hate to be overpressured. They don't like temperature extremes. Room temperature is the best. Cold, hot is bad, right? They're diverse in shape, chemistry, and all kind of sizes. That's the only place I want less diversity. I wish we had some standardization eventually. They're statistically faulty, and they're all going to die. Okay, so having in mind that, what I started doing in my first act in this battery lifetime is to actually make sure I protect the battery and make sure I stretch their first life. And how do I do that? With the so-called battery management system, which basically measures current and voltage from the batteries, and then tells you basically how far you can go with that one charge. But guess what? So that's the state of charge estimation. And then the next one is state of health estimation, and that means it tells you how much of charge the battery can hold. Why? Because batteries are aging, and they slowly kind of lose their capacity, and we'll talk a little bit about that, a lot actually about that. So this is the state of health, the reduction of capacity. They also have a balancing algorithms because all the cells kind of die differently, like humans. I mean, kind of age differently, like humans, and they're all going to have to be a little bit balanced in a pack. And then, of course, compute, be the policeman in some sense, and compute power limits and act on them. So let me, I'm gonna do a quiz this time. Okay, so watch. Okay, so we have 3 battery packs: the A, the B, and the C. They're on vehicles used by different people. And as you notice, United Nations Global Technical Requirements and CARB requirements tell us that the battery should not die. The warranty expects that the battery should not decay or lose capacity more than 30% in 8 years. Actually, 2026 models, all of them have to actually last for 100,000 miles and 10 years. And so their capacity actually has to be higher than 80%, the retention. So we keep on moving this standard. So all these dots, as you can see, the red are actually the same. So what do we have here? We have a system. Of course, we're engineers, and we're going to sell the batteries. So if there is a policy that says this is the requirement, guess what? Industry is going to do it. And all the dots are in the same spot. But obviously here, what you can see is that although all of them have the same health, they have very different remaining useful life, which is that green arrow. And that says that basically obviously we want to buy, if I want to buy a used car, we will buy the middle one, because that's going to last longer if we're going to buy it. And so this is basically the remaining useful life suggests that what we want to do is that one state of health value is not enough, and we need to track it over time. Okay, another issue is, even if we are tracking it over time, if the pack goes away from the from that vehicle and goes into the grid or something else, there's no way to extrapolate anymore, right? So even tracking it will be actually completely different behavior. So in fact, here, we need to have a deep estimation of the states, and this is like exactly what controls people are trying to do, is take a look at the features and try to actually estimate if there is remaining useful life, what is the health and what's the underlying state. So the battery second act goes like this. I was lucky to be, again, in Michigan, and next to me was like a lot of recyclers. And recycling, a lot of lithium-ion batteries that go to recycling are actually a lot of these power tools that we use for handymen and all these things. The medical school creates a lot of batteries waste that they go to this recycler, so we get buckets of them. And we were basically testing them, trying to understand what is going on, and this is how it looks like. So do you remember that nice 5 layers of the battery? Now you see kind of a mess. It looks actually like a coronavirus kind of thing, because a lot of things are not happening exactly, and the lithium is not exactly intercalating nicely in the material. It piles up, it actually dissolves, and you have a lot of different degradation modes. So basically, we're gonna run a digital twin. And the idea is, wow, okay, now you're gonna see math? No, no, no. My point is that, like Sergey said, I saw this, I saw the need. I didn't know basically how to do it, but I knew I had to try it. So I had to actually start writing the equations that a lot of chemists and materials people have, and write all the equations down and try to actually take data from old batteries and parameterize this model. And in fact, it's very hard. And it's very hard because, as you can see, the hard part is not the equations and writing down the equations. The hard part is that these equations interact, and because of the nonlinear interactions, they create a lot of nonlinear issues that are very difficult to characterize unless you actually, now I'll show you an example here. This is a battery that keeps on decaying, so it actually decays its capacity, and then suddenly a knee. So what is happening here? So it was actually building up in this, what we call SCI layer, and after some SCI layer, it started building plating. And the plating is the one nonlinearity that creates this sudden knee. So we actually put them together in a nice map, and we started sort of trying to actually write these equations down, take data and parameterize them, a physics-based data-driven approach. And basically, we understood, wow, these are too many parameters. This is like driving blind. I have to do too much work. This is impossible. And guess what? We went to the lab. We kept on going. And by, to be honest, amazing luck, we developed this system where it measures the lifetime battery thickness. So not just electrical signals, but it actually measures how the battery swells. And the battery swells. I show you here some graphs from fresh and aged cell. And as the batteries basically age, so when they run, the lithium goes into the graphite and it swells. It's kind of like breathing. And then when it discharges, it contracts. So it's like breathing. So it actually has a little motion in micrometers. And also, as it ages, it builds up this material that you can actually measure with microns in real time. And now I'm going to go to my batteries like humans and say, hey, cells breathe like humans and also growing a waistline as they age. Now, guess what? The packs, they grow as they age, but they're stuck in the same pack. They don't go buy a new pair of pants, right? So now the pressure builds up, and because the pressure builds up, it's like, again, another feedback loop that actually causes the degradation. It is a very important topic in a sense that now we need to actually capture this degradation as accelerated phenomena because, again, we need to decide if we need to repair, refurbish, and that's a large industry that is happening for internal combustion engines, so we want to maintain it around us. Okay, I'm going to get to the safety epilogue here, which means that one of the biggest decisions when you want to repurpose a battery or take it from your car, or if you are a school, to take it from the electric school buses and put it in some area so that you can store energy from solar and get more resilient, you want to make sure it's safe. And I want to say that these batteries are like human, and angry cells need to vent. So the first actually instance that the batteries thinks the battery gets abused and it's unsafe, it's when it swells abnormally, and you can actually also measure it with this material, with this scheme we have. And basically, you can see, you can apply it in microelectronics and cell phones all the way to large facilities. And we are developing, again, at the Auto Lab schemes for building up a lot of training programs that community colleges would actually move to associate degrees. And thanks a lot for listening.
Thank you very much. Questions are available. Yes, thank you. There's a microphone coming your way.
Hi, you may have answered this in the presentation, but I am not a mechanical engineer. I bought an EV a couple of years ago, and upon purchase, I was advised to never charge it to 100% because battery longevity was peaked kind of in between a 20% and an 80% range. And I've always wondered why that is. Can you help in layman's terms explain that?
Yes,
and if it's even correct?
So it's actually very easy to imagine. So you have the anode and the cathode, remember these layers? So when your graphite is almost fully full, it's almost full, so you're at 80%. When you send a lithium across, it kind of like piles instead of just packing in, because most of the sites are now full. So when it tacks in and then you are there, you have higher probability of plating. And plating is the part that when you're plating, you basically can have metallic lithium that actually crosses and creates sorts. And that's why when we have recalls, most of the recalls, if you remember, they would do some software changes so that they limit actually initially your battery charging to not go above 80% to avoid that region that it is tricky. So do it only when you have to travel far, but not often. Also in the winter, it's okay, to be honest. It's in the summer. Well, actually, no. In the winter, it's worse. Forget it. Yeah. Good? Okay.
There's a question here.
Car talk. Yeah. There's a question.
So I'm not a mechanical engineer either. But I understand that hydrogen fuel cells are like an alternative source that's becoming commercialized. Is that something that you could see used commonly in the near future in automobiles?
Large things, not small, very large. The energy density and the specific energy is not close, and the cost is very high. So it's only for large heavy-duty vehicles, 18-wheelers and above. Potentially trains, ships, maybe. Yeah. So cars like you and I that we parked 80% of the time and we're just driving it for no more than 35 miles, batteries.
One final question.
Hi, Professor. I had a question about, is there any work or have you found anything that has determined how extreme weather affects either like speeding up the degradation of batteries, like extreme cold or extreme heat?
Yes. It's actually, yesterday I was trying to finish this talk, and obviously I cramped too many slides. I went too fast, but I was getting calls to have an interview regarding in Boston and in New York. Because of the bad weather, some electric school buses did not get out. And a lot of people were really, really mad. Of course, they were blaming batteries and all that stuff. And the point is that you ideally want to plug in your vehicle, your electric vehicle overnight, so that the battery its temperature doesn't go really, really below freezing. So this way you can drive and use basically your battery in as full as possible with the right temperature above freezing. Above freezing, there are many things like we cannot do regenerative braking because, again, it's cold and we don't want the lithium to pile. We cannot charge very fast, so if you're low in charging, you cannot even charge it. You have to first discharge it to heat it up and then charge it. It's kind of fascinating. But we all learn. In Norway and other places in the world, we know how to do it, and it's the human can adapt as needed. I think we just need to learn how to work with electric vehicles, and it's so much easier if you have a plug. I actually don't even have a home charger, thank goodness for the University of Michigan. It has 6 chargers at the North Campus. That's where I go and I charge. So.
Thank you for that. Very, very intricate and complex. Let's join me in thanking our distinguished university professor.
Thank you, Professor Stephanopoulos, for your engaging presentation and for recharging our intellectual batteries. And now please join me in welcoming our final lecturer. Christian Davenport is the Charles Tilly Distinguished University Professor. He's a professor of political science and of Afro-American and African Studies in the College of Literature, Science, and the Arts, and a professor of public policy in the Gerald R. Ford School of Public Policy. For nearly 30 years, Professor Davenport has been at the forefront of studying state and non-state uses of coercion and force, examining how political conflict and repression begin, escalate, de-escalate, recur, and shape societies. Across 5 books and more than 50 articles, his scholarship has influenced not only academic thinking, but also governments and civil society institutions around the world. His work has been supported by numerous grants, including 12 from the National Science Foundation, and recognized with major honors, including a fellowship with the American Academy of Arts and Sciences and a Best Book Award from the American Political Science Association. His lecture is titled Rebels, Repressors, Regular Folk, and Me, a 30-year reflection of the last 75 years in 20 minutes. We're in for a treat. Drawing on quantitative, qualitative, and artistic approaches, he will reflect on what drives political conflict and violence and what it changes when it occurs. How timely. Please join me in welcoming Professor Christian Davenport.
Forgive the snark, everyone. I was trying to figure out what to call it. That was very difficult to do. But what's up? So thank you, nominators, the selection committee, distinguished folk, regular folk, everybody. Thank you very much for this. I think short on time, I'll write a more appropriate thank you for everybody and detail that. But yo, let me jump in. So for 30 years, I've been studying the dynamic interaction between governments, behavioral challengers, and civilians as they compete for influence over the creation, objectives, composition, as well as policies enacted by political authorities. And this is the important part, using some form of coercion and force in order to do this, generally outside of the institutionalized nature of politics, but sometimes within it. Charles Tilly, the former Michigan social scientist, friend, mentor, marvel, and person I named the chair after will probably accept my calling this the domain of contentious politics. In my conception, as in most things, I follow Chuck's lead. I'm a scholar born of many mothers, and I probably identify him as perhaps the most important. So this, for me, was a great way to return all the gifts that he had given to me. I was looking for a photo of Chuck and myself for this talk, but I realized that maybe I came from a time when one did not take a picture with their esteemed intellectual mentor. So, that's the best I could find. That's me sitting behind him at a workshop in 2007. But quickly, though, let me before I get to the talk, let me give you the 5 things I learned from Chuck and why I named the position after him. And one is, Chuck gave you a model of engagement. One time he said, this is his way of doing it. He's like, you have the way you did it, and then he'd give you 2 other ways and never tell you which is the best way. And then you just realize that there was many ways to do something. A model of encouragement. And he's like, I think you're a book writer, stuck in an article writer. And then with that inspiration, I then started writing books. A model for a workshop, he was like, always run one wherever you go, surprises abound. A model of communication, he's like, be you, but tone down the New Yorker a little bit. And I was like, all right, man. And a model of mentorship meets sponsorship. He provided timely comments, sent people my way, invited me to stuff that I know I would have gotten into. And he was always present and open for whatever, and wrote letters repeatedly. And so let me get to it. Chuck would like that. As I was thinking about the talk, I came to view this day as like, it's part victory lap, it's part mixtape, it's part guidebook for the journey I've been on. And so also kind of help folks understand me, my work, and life a little bit better. So I figured I would take a slightly different take. So I've endeavored to understand why each actor in this figure is kind of doing what they do and with what effect. While I maintain that all 3 actors and the actions associated with them need to be examined at the same time, for most of my career I've basically focused in on governments and political authorities, and this is because they have the preponderant capability to destroy and subjugate human beings. So if you're going to focus on somebody, you might as well go for the actor that could do the most damage. I generally study the subject broadly, focus on a wide number of countries post-World War II, but I've also focused in on a few cases as well, the US, Rwanda, Northern Ireland, and more recently Colombia, as well as Brazil. This work is usually done with reliance upon quantitative analysis, but a bunch of qualitative stuff finds its way in there as well to better understand human decision-making. There's 2 major takeaways from my work. Governments are the primary actors in contentious politics and not behavioral challengers. Not revolutionaries, rebels, terrorists, protesters, rioters, or troublemakers. Governments are the main point of action. And second, humans as individuals as well as collectivities have an incredible ability to survive, adapt, and occasionally shift the government course of enforceful behavior directed at them. But through the manipulation of threats, they can also be led directly into the throes of the very state and course of behavior that they're trying to overcome. But this is where we're going to end up. I want you to understand a little bit about how we get there. And to do that, y'all gonna strap yourselves in because we're gonna just like move through a whole bunch of stuff very quickly. So for me, it all starts with Clark University, bless you. Clark University in Worcester, Massachusetts. As I'm black, it's normally associated, the other Clark University, so I'm always like, no, not that one. And there I took this class with Cynthia Enloe, who was like radical feminist. But the class was Revolutions and Systems Change. And she's just incredibly giving. But one day Cynthia stated, the greatest advancements for humans were brought about by the efforts to challenge and modify governments and elites. It's like, just imagine being an undergrad hearing that. You're just like, oh, what do we do? And to demonstrate this point, she focused on a variety of Central and Latin American struggles, and she brought those people into class, which ended up always getting us in trouble because there'd always be someone from the CIA or some other organization coming to ask us what the Sandinista just said or what this person from Cuba just said, which was fascinating in and of itself. But she was joined in her efforts to educate us by Professor Zinovia Socher, who is a Sovietologist, and it turns out to be a Ukrainian expert. Zinovia taught us about the Russian Revolution. With these experiences, I had my first relationship of interest, just like, oh, okay, challengers to governments, when, why, how, and to what effect. I was guided here not only by my coursework, but my own life. Being an African American and from New York, I had a faint awareness of the civil rights movement. Well, black person doesn't. And later the Black Power movement through a family friend, Gil Scott Heron, who in summers would like regale me with all these things that I didn't know, which was incredibly helpful. And being an American, I had a faint awareness of the American Revolution, pre-Hamilton awareness. I also had a light participation in the anti-apartheid movement of the time with the shanty towns and the calls for divestment. and some participation in a series of protests to save a beloved professor, Ken Trachty, who was getting dismissed because he wasn't doing research, but whatever. Puzzled about the seeming importance of movements and activities related to them, but this apparent lack of effectiveness in my own experiences, but also the other ones that I was studying. I went to grad school to figure out how change-making efforts could work and under what circumstances they could succeed. And this took me to Binghamton. It'll sound odd to hear it stated the way I'm going to say it, but while looking for an answer to social movement efficacy, I discovered the state. And this was in part because the state was kind of light in all the discussions of the revolution and all these other things that Zenobia and Cynthia were talking about. But the key intuition from these initial explorations was that behavioral challenges may fail in part because they're organizations set up to counter and destroy them, which sounds fairly straightforward now, but at the time, it was not. And so with this, my eyes focused on understanding state, political, government repression. And here I was led to ask, what was repressive behavior and why was it used? And the short answer was simple. We didn't really know much at the time. The topic was open, and in many respects, that's what the grad student looks for, right? I'm like, therein lies where I should go. So I went to grad school, and then in that space, I began to craft my research, figuring out exactly what I would study and importantly where, and enter Rick Hofferbert, the villain in our story. He was a comparative politics person and a Southern ungentleman, and at some departmental barbecue, you've all been there, he asked me over some beverage, Christian, what American city or African country are you going to study? I'm like, what? Where'd you get that from? And so I mentioned I was aware of the civil rights movement, the Black Power movements, but right then and there, mostly out of spite, I decided I was going to study the world. So I was not going to let Rick or anybody like that define what I could do. In retrospect, this was possibly the best decision I could have possibly made. And in this context, I fully joined the international relations and world politics community and created one of the first cross-national investigations of state repression of all countries from 48 to 82, exploring what we then called negative sanctions or political and civil liberties restrictions. And the key insight from this work, state repression was an important strategic decision made by governments driven by diverse political and economic and demographic factors. Most prominently, this included political institutions and behavioral challenges. And with this, I left grad school. And I went to my first and second jobs. Now, I put these two institutions together because it was during this time that I expanded on my initial efforts. It's no offense to either one, but I continued what it is that I was doing with two lines of inquiry. Also, I wasn't at either place that long, just a couple of years. And there are several key insights from the institution's work. I discovered what I called the domestic democratic peace, where democratic institutions and practices are less likely to repress relative to autocracies. Repression was decreased by the occurrence and quality of elections. Repression was decreased by moving towards an election, but after the election happened, you basically went back to the level of repression you had beforehand. Constitutional provisions that allowed for repression generally led to governments to use it, and I discovered what I call the tyrannical peace, where it was found that not all authoritarian governments are alike. Totalitarian systems use way more repression than military systems, which use way more repression than single-party systems. And then several insights from the work concerning behavioral challenges. Repression is generally increased when behavioral challenges are more frequent or severe or deviate from cultural norms. And this relationship was important for it led me back to the Clark question, but with a grad school insight. Repression influenced dissent, dissent influenced repression, the so-called conflict-repression nexus. Here I explored who started political conflict, what they did, how these activities were responded to, how these responses were responded to, and the co-evolutionary dynamics involved. And the CR nexus led to diverse insights. Governments generally started conflicts, as there's no revolution, there's no insurgency, there's no terrorism, there's no protest, no resistance without a prior government behavior that starts the whole thing on its way. And challenges always prompted additional government behavior, the counters, counterinsurgency, counterterrorism, counter-repression, counter-revolution. But the magnitude of government response was increased by the degree of threat contained. I then examined how context influenced conflict dynamics and its subsequent evolution, and this led to perhaps one of my most important findings, the Achilles heel of the domestic democratic peace. Democracies generally repress less unless there's a behavioral challenge, at which point they repress at similar levels to authoritarian governments. Now, with tenure up to this point, I still maintained a global orientation, but I became interested in specific cases, returning to my pre-Rick self. Of course, with Rick still in my head, I was not interested in just the African-American case, but other situations of ethnic persecution and resistance, rebellion, and then one day, opportunity knocked. Third job, University of Maryland. Here I was asked by the late, great Ted Gurr to run a project, or two projects actually, Minorities at Risk and something called Polity. Minorities at Risk covered 300 plus ethnic groups that were persecuted and or engaging in some form of resistance behavior, and Polity involved measuring authority patterns for all nations of the world from 1800 to the late 1900s, early 2000s at the time. The part of the job that involved these projects, however, didn't work out. I didn't realize that my job was to keep the projects running as they were established initially. And I really had no interest in doing that because I thought that my job was to help the projects evolve and move in different directions. And while I was in Maryland, I realized I no longer wanted to explore whole countries exclusively. Rather, I wanted to examine regions and communes and cities and villages within an individual country over time. And so I ended up studying several of these on the way, Rwanda, India, Northern Ireland. The difference in this approach is important because in exploring Rwanda, you're not comparing it to Congo or Indonesia, you're comparing different regions in Rwanda to one another. And actually, my friend and dear colleague Dave Armstrong is in the room. And so Dave was a grad student at the time when we pulled him into this project on Rwanda, and so I'm incredibly happy that he's here. This approach would later be called subnational conflict studies. The figure itself is from a project that ended with me getting kicked out of Rwanda, told never to return, and labeled a genocide denier because we were accused of trivializing the anti-Tutsi violence by providing a lower estimate and a higher estimate along with all of our information. The lower estimate was deemed to be trivializing the genocide, which was illegal in the context of Rwanda. And so we were identified as genocide deniers. Well, not all of us. I don't think Dave got identified as a genocide denier, but those of us at the top of the project. The key insights from this subnational work: within the same territory, governments use coercive and forceful behavior against government or groups differently in accordance to perceived behavioral challenges, proximity to other groups, and proximity to valuable resources. Additionally, my work reveals that government challenger interactions of one type, protest policing, for example, leads to government challenger interactions of other types, civil wars, coups, and revolutions. And while engaged in this work, I became aware of something very important, that not all government actions were directed against civilians, or challengers, sorry. Indeed, I became very shocked about the fact that a whole bunch of behavior would be directed against people who weren't explicitly challenging anyone, and that was a key insight. Civilians are important witnesses and they're participants. They could stay neutral, or they can join challengers, or they could join governments. But what would drive individuals one way or the other? And while I was trying to figure that out, I got a call, and quickly after that, another one. And this led to jobs 4 and 5, Notre Dame and Michigan. Now, to be clear, I put these two institutions together because I started something at Notre Dame, and then y'all gave me the call, and I came here. And so, go blue. Go blue. What's up? Yo, really? It only works for strangers. It doesn't work at home. Okay, fine. All right. So generally, I view this period of my work of reflection, discussion, refinement, tool-making, creativity, and extensive collaboration. And so 4 things happened during this time. First, I continued to reconceptualize, theorize, and examine more encompassing ideas about contentious politics. For example, with my former student and friend, and compatriot of Dave, Ben Apple, we discovered that basically everything we thought we knew about state repression was basically wrong. We found that the guiding theory for repression should not be the rationalism that it was basically characterized as, but something else perhaps initially rooted in it, but steps away from it as it begins to generate momentum. In addition to shifting theory, we discovered spells, episodes, campaigns were a better way to understand the phenomena as well as examine it relative to alternatives. In this framework, we needed to highlight onset, escalation, de-escalation, termination, recurrence. We also discovered that these distinct aspects of the phenomena were led by or influenced by distinct political economic factors. With Dave, Hovard Nygaard, and Hannah Feld, we discovered that a lot of what we thought about contention broadly conceived was basically wrong. Indeed, we discovered that a great many forms of political conflict and violence fit together conceptually and empirically, allowing us to create a uniform index of government challenger interaction, what we call relative contention. And here we need to think of government challenger interactions at the same time. So civil war is actually composed of counterinsurgency and insurgency, but we talk about it like it's a singular thing, but we think that all forms of contention fall into a similar kind of dynamic. Now, while both sides are responsible for political conflict and violence, we also discover that governments have the greatest impact on politics and economics, not just the short term, 5 to 10 years, but longer terms as well, 25 to 50. With my former student and now friend, Yusuf Monaher, we started the Transnational Repression Project. Here we shift away from the traditional focus on what takes place within territorial units to acknowledge that governments don't stop at their borders to go after opponents. They, like Rwanda, will follow them wherever they go and sometimes get other governments to do it for them. With this project, we're bringing together a bunch of information and some new data. Now, second, I've attempted to further my examination of how government challenger interactions impact civilians. In this space, again, I began a series of experiments with Dave, Rose McDermott, and others, where we explore individual opinion about different contentious activities and how that influences what government, or how government challenger interactions influence what they think and what they're willing to do. And some quick insights from this work reveal civilians have measurable sense regarding the degree of coercion and force among tactics employed by each side. Civilians appear to view more negatively the person that's most aggressive in these interactions and view the other one more favorably. Stepping away from language and acknowledging that your descriptions of how events working out, I moved to this thing called visual elicitations, where individuals would take images and they'd place them into sequence, and those sequences would then be informing us what was going on or what they think is going on, like appropriate or acceptable or illegal. Then I began to collaborate. While at Michigan, for the first time, I started teaching with other people. I discovered other human beings, which was great. Unfortunately, they leave, right? So Derek Darby, who's in philosophy, we did a class on radicalism. We did a podcast. We developed a computer program to assist in analyzing radicalism of texts. With my dear friend Dan Slater, we did a class initially. Sorry, bro, I took that picture. We've collaborated on a few amazing visitations to bring people to Michigan. This is the late, great Jim Scott. And then with my old friend from Houston, remember that job, renowned artist Rick Lowe, who just came recently actually to Michigan Theater to give a talk. We've done 2 classes on Black progress. After seeing the Anti-Black Human Rights Violations Project that Dave and I did from 1860 to 2010, he compelled me to say, hey, why don't you paint that? And so I listened to Rick, I started painting it. He incorporated that within this piece, which will be in the UMA in August, along with the rest of the exhibition. And finally, acknowledging and processing my own experiences and exposure to government challenger interactions, I began to put myself into the civilian category. And this has involved reflecting about what I saw as well as what I tried to do in Rwanda. And it acknowledged in many respects, I tried to think about exactly how you could talk to someone about what happened to George Floyd, as well as allow for a co-evolving series of conversations while doing so. That project is helpful because it is actually, I'm collaborating with my mother, who's a fine artist and a graphic designer. And finally, I'm working on discussing everything that I've kind of figured out about state repression over the past 30 years by paying attention to it. This is the book that I'm working on now. It's also the class that I'm teaching. I just had that earlier today. And with this, I want to thank you for letting me share a little bit of my journey. But that's kind of the journey. But of course, I want to acknowledge there's more, there's always more, but we're not going to talk about that now. We'll let that go. And so thank you very much.
Thank you. Questions for our distinguished university professor? I'm happy to lead off.
Yeah.
Could you, so I saw that you kind of put governments as the origin. Could you talk a little bit about how a civilian becomes a challenger, or are challengers, do you think of them as being kind of internally created, or are they sometimes external? And I'm just trying to understand on those 2 axes how one becomes the other in their relationship. Thanks.
So I would start with Renee Good, but I could start with George Floyd, or I could start with, I always forget the kid's name that was killed, that's identified as starting the kind of Arab Spring. But there's these, the reason why I started thinking about people's perceptions of government challenger interactions. We have in our heads these ideas of what's deemed to be legitimate, and when something happens that exceeds the parameters of what we think is acceptable, then we're ready to become a challenger. Now, whether or not the challengers see that opportunity and they cultivate you properly, or they're not advocating the right tactic, or they're in the wrong geographic location, that doesn't always properly work out, but you might be motivated to do it. So if you think of the conversations that people had after Renee Good, it was very clear that we thought something was wrong. Most people thought something was wrong, and they were willing to do something about it, but they weren't quite sure what to do. We get to George Floyd and the Black Lives Matter movement in part because the people that saw that and experienced it were just like, that's not acceptable for us, and they were willing to do something. Now, how that's harnessed, what that leads to, that's a slightly different issue. So we have the largest protest we had in American history, and then it kind of went away. And then the police behavior wasn't necessarily perturbed or dramatically shifted. There was something that was missing between that sentiment of how you became willing to challenge and step out there, and then kind of like what that led to in terms of actual change. And so they don't always match. But I think we get the civilian to challenger in part because of these perceptions of inappropriate behavior, or, okay, that was too much. And then you're open to it. And then it's about being harnessed into it, being fed by it, being understood within that space, and also seeing some efficacy. And if you don't see that relatively quickly, then your commitment level is diminished. So.
Thanks. So you're saying there's a kind of agency in a challenger. It's not that the government is identifying a group as the challenger.
That happens too. That happens too. But it is way more dynamic than we normally think of. But if you go back to the 50s, I mean, the Communist Party was trying to recruit. I mean, the Black Panthers trying to recruit. The new Black Panther Party is trying to recruit, But this all is related to whether or not civilians are willing to join is something completely different. And that's related in part to this calibration between what governments are doing and what challengers are doing and who they're seeing as being reasonable or perhaps able to kind of like support them. Yeah.
Other questions?
One over here.
Oh, thank you.
Thanks, Christian. Knowing what's been left out of here, I want to sort of have you think about the other way around. So the Christian from when I was in graduate school came up with the tyrannical piece, but my guess is the Christian now wouldn't think that's peace at all, probably. Yeah. So how has your thought about sort of what makes or kind of what stands in for peace changed over time relative to conflict?
Ouch. So this is one of those things, like Dave Chappelle's got this piece on like the 3 Dave Chappelles. So the idea of having the younger me thrown at me is just kind of jacked up, man, but okay. I think that the whole, sorry about the voice, I think the whole literature in many respects, we were compelled to think about how to modify behavior. And we were like, torture's bad, mass killing's bad, arrests are bad. And that became our fixation, and we were just trying to reduce those things. We didn't realize exactly what it meant if someone wasn't being killed out in the street. That's better than them being killed, but we didn't really get to the idea of how liberated or free or well-intentioned or well-educated they were. We were caught by these ideas of thinking about the manifestations of the violence, and that was the focal point, not the 30-year after effect of not funding education properly. We didn't think about that. So it's like we missed the other models of subjugation that Weber talks about, right? It's just like, okay, I might not need to kill you because you don't have any good ideas that are challenging to me. Yo, that's a completely different program. But we succeeded and we got rid of torture and disappearances. And so I think that the new me is very much caught with trying to figure out exactly how we could have more emancipatory conceptions of what freedom is, what power is, and stepping away from, okay, I'm not getting beaten at this moment, but I don't have any good ideas about how to fix the situation that we're in. And so that the peace book that I wrote identified that negative peace is normally the absence of violence, but positive peace was these more highly informed ideas about how we all could get together or build something together or see some identity that we could all put together in some way, shape, or form. And so I think we're now in that positive peace space where we need to talk about what those are. I have some class that I want to do, which is like poly sci-fi, which is just kind of like, we need to imagine the beloved community, right? It's just like, what is that community composed of? What's it look like? How do we speak in that way? What do politics look like in that space? I'm reading Octavia Butler to get a sense of these imagined communities, and we just don't have enough of that, right? We're just kind of caught with like, let me just vote for this party and it'll all be good. But we haven't thought about, okay, what's that supposed to lead to? How's that fit in? And I don't think when I was doing that earlier work, I was at all thinking about that. I was kind of like, let's stop people getting shot in the head. I wasn't thinking about, well, just because I'm not shooting you doesn't mean that you're properly educated and ready to kind of like fight for a better world. So that's messed up, dude. Thank you, though.
Final question. Thank you.
Okay. So we learned from the last talk that batteries are a lot like people. And I think we all learned from this talk that some people are a lot like batteries. They have a lot of fuel, they got a lot of energy, they do an incredible amount of work, and it's just unbelievable all you've done. But I want to talk about the fuel a little bit, the lithium, what powers the battery. And you said at the beginning, you told this story, which you've told me before, about the insult that you received and the spite that triggered in you and say, I'm gonna study the world. You think I can't study the world? I'm gonna study the world. And later on in your career, Rwanda kicks you out, and so you double down and you do even more on Rwanda when they tell you not to do it. So I'd like to hear a little bit, and I was thinking about the grad students here behind me, thinking like, we don't tell grad students to follow their spite or follow their anger or, these things to prove. Can you reflect a little bit on just the course of your career, how that has influenced you? And both, because you're driven by love more than anything, but sometimes there's some anger, and sometimes there's some spite, and there's something to prove. And can you talk a little bit about, as a younger scholar, as a more mature scholar, how those different emotions have motivated and fueled you?
Great question. I feel like I'm thinking of conversations we have about like, is it fear or is it anger? I'm just like, the ability to parse them is very difficult. So while listening to Rick, I felt angered at the fact that he was trying to narrow me. He'd be like, well, you're black, ergo, you're going to do race and politics, ergo, you're going to do a city. Oh, but maybe you'll throw in a spin and do something comparative. And I'm just like, so there was the anger that was there at like, how are you trying to put me in a box? There was that. And at the same time, I was kind of like, well, Cynthia studies all these other places, Zenobia studies all these other places. I was at Binghamton, so I was working with Emmanuel Wallerstein. He's doing world systems theory, and I'm just like, and then like that introduced me to Sheikh Anta Diop, who did all types of theorization about like early Egyptian civilization and so forth. So I was just like, why are you trying to narrow me, man? And so that kind of like kicked in. But then I'm kind of like, I think later on, it's like, so I want to move from violence and conflict to love, really. Jim Morrow, my colleague and friend now, made the comment, he's just like, you might be done with violence, but it might not be done with you. And so I think that's kind of jacked up. But I've been thinking about this idea of, I love humanity, I love freedom. And so there's that concurrently with this other dynamic. And I think all of these boxes and limitations that we're placing on subfields and topics and methodologies and so forth, they're just narrowing our ability to do things. And so whether or not it's spite and or love that's motivating me to push back against any of these kind of like hindrances, I'm kind of going, I guess the rebellious spirit is there, perhaps fueled by both. So I don't know that I think I might have been anti-Rick in grad school. And then after a while, he became completely irrelevant. And then once I was immersed in the kind of like world and international relations field, I completely forgot about him, which is good in so many ways. But yeah, that was still there. As people who know me know, I hold a vendetta. I'm like, Christ did not just ignore the money changers, he addressed them directly. So I'm just kind of going, all right, the spite feeds on the love, but also leads to this more encompassing thing. I think it's just been a broad sweep. And every limitation that I saw was like an invitation to kind of like read more and read around. And so I'm not completely sure that answers your question, but yeah.
Please join me in thanking Professor Davenport for his lecture.
Thank you.
This concludes our symposium for the Distinguished University Professors. There's a reception that is beginning now. Please stay to enjoy company and meet our Distinguished University Professors, and let's give the three of them a final round of applause. Thank you.